In this video, we'll consider problems constructing of truth table for biconditional of expression that involves biconditional and conditional statements. Um, for some reason, these type of expressions are kind of creating a lot of confusions, especially truth tables, and in general, create a lot of confusions. So I will try to show you how to deal with these type of expressions and show your work and get the values based on basic um, basic truth tables for conditional and basic and biconditional expressions. So our expression is or our expressions are, first one is negation of p. It's equivalent to the q. So negation of p with biconditional statement equivalent to q. And p, the second one is p implies the negation of q. In order to find the truth values of these expressions, we are going to refer to the truth values of conditional and biconditional statements. So the conditional statement is here, and the biconditional statement is given in this table. So how do we deal with that? First of all, let's try and understand what does that mean the arguments are like building or forming the biconditional statement. The value here, the values of the biconditional statement are found as the following. So if the first arguments, like both arguments have the same value, then the result of the biconditional statement is true. If the values of P and Q, or the first and second values, are different, then they are not equivalent. So it means that the result of the biconditional statement is false. So what do? Is we look at the values in the first and second column here. So true and true, they are the same. It leads to true. False and false, they are the same. So it leads to true. So whenever they are the same, the answer is true. True and false, they are different. So the answer is false. False and true, they are different. The answer is false. So whenever the first and second arguments are the same, then the result is true. Otherwise, the result is false. What about the conditional statement? The result of the conditional statement is false only if the first argument is true and the second one is false. In all the other cases, it's true. So if the first one is true, the second one is false. So if the promise is true, but the conclusion is false, then the result of the conditional expression is false. Otherwise, it's true. Okay, so we're going to use these two tables as the base tables, and then find the expression, the valid truth tables, truth values for our expressions. Okay, so let's look at this. Let's look at the first one here. So we see that instead of P, we have the negation of P, but Q is the same. So what does that mean? It means that the value of this expression is going to be found based on the values of the negation of P and Q. It's not based on the values of P and Q. No, it's based on the values of negation of P and Q. All right. So it means that we need to have the extra column in our resulting table that expresses the values of negation of P. Okay, so I'm going to add that column here. So I'm going to put the negation of P here and write the values of the negation of P. Those values are found based on the values of the first column here and just negating them. So the first value is true, then we have negation of P being false. Second value is true, the negation of P is false. The false value leads to true, and the false value again leads to true. Okay, so I have the column for negation of P. Now I can write the expression for my problem in the next column. Okay, now how do I find this? the values of this, the truth values for this column. They are found based, as I mentioned again, based on this column now and this one. So this is my first value, or these are my first values, and these are the second values. So what I'm doing, I'm taking this false value here and the true here, and going to this table and try to find them in this table. My first argument is false, false. The second one is true. Then my resulting value has to be false. So I'm writing false here. Okay. Then what do we do next is, again, we're looking at this false and, sorry, this false and this false here. So the second values and the values in the second row. So this is my first argument, the value of my first argument. This is the value of my second argument. So I'm going here and see first one is false, second is false. The result is true, obviously, because they are equivalent. So the result is true here. Okay. Then I'm going back, I'm going to my table and see true for the first, true for the second. They are equivalent, and the result is true. And finally, the true for the first one and false for the second one, they are different. And based on my table here, when the true and false values, the result is false. So my result is going to be false here. All right, so that completes the truth values for the first expression. What about the second expression? Looking at the second expression here, we see that it's based on P and the negation of Q. So we need a column for the negation of Q to get the values of this expression. So I'm going to write negation of Q here. And then I will put my expression next to it. Negation of Q. All right. So first we get the values for the negation of Q. So they are found based on this column here, right? So we get the first one is true. The negation is going to be, negation of that is going to be false. False leads to true. Again, true leads to false. And false leads to true. Okay. Now we got to use the values of the P column and the negation of Q column to get the values for this. Okay. All right. So the first value is true. The second value is false. I'm going to this table here. The first value is true. The second one is false. The conclusion is false. So writing it here. Then getting back to the values again. The first value is true. The second is true. And that matches with this. So the conclusion is true. Then we have the first value being false. The second value is being false. Based on this table here, based on this, we can conclude that this one is also going to be true. And finally, the first value is false. The second value is true. And based on this row here, we see that the conclusion is true. Okay, so this completes the truth table for both of these expressions. And I hope it will help you to understand how to deal with these type of things. And I hope it clears some confusions on how to show your work building or constructing the truth tables for some statements, for expressions.